Hello and welcome back to the Lee channel. Today we have here an assignment that I'm going to walk you through, the Phet simulation moving man inquiry assignment. The purpose of this assignment is to get you to visualize what motion looks like when acceleration is involved and how that affects your velocity over time. If you're going in one direction versus the other, when are you speeding up, when are you slowing down? And also introducing you to the idea of negative acceleration, because in everyday life you never say someone has negative acceleration. What does a negative acceleration mean? In part 1 you'll get to visualize the acceleration velocity vectors and what the moving man, how he is moving in regards to that. The second part of the assignment is to get you to visualize how this motion would look like on your position, velocity, and time graphs. And last but not least, right at the very end, when you finish everything, you do want to complete this exit slip, hand it in, so that I get to see whether or not you've understood the learning outcomes in this assignment. Okay, so let's get started. And this Phet simulation, we need to go on Google. So set up instructions, Google Phet simulation moving man, click the first link. Okay, so let's go here. And by the way, you can pause me anytime to write something in your assignment, etc. Okay? Alright, so Phet simulation moving man. This should be the first hit. Bam. Okay. Unfortunately, this simulation can only be run with Java. So please install Java on your computer. No, it's not a virus. And I'm assuming you have, so all you need to do now is download the simulation and wait for it to finish. I'm going to keep it. I'm going to open it. This is what it's going to look like if you have Java installed. So okay, Okay, so this is what it looks like when it's loading. Alright, this is what you get first. This is the first tab, the introduction tab here. So let's read the instructions on what needs to be done. Oh, I opened 2 of them. So let's close one of them. Okay, perfect. Okay, so you should see the following window, and there we go. We see the following window, open the file, download, make sure you have it. Okay. So first part, we're going to visualize these vectors. How does acceleration affect velocity, etc. Part 1. This is when your velocity and your acceleration are both in the positive direction. Number 1, you must check the velocity and acceleration vector before you start. And this is really to help you visualize how these vectors change over time. Okay, next step. Click and drag the man all the way to the left side. Bam. That's the left side. Ooh, you might even hear some sound. Okay, so it's playing. And that's why here you want to hit the pause button and clear the simulation. I want to pause it. I want to clear it. So now I have this guy here. And we can now slide the velocity toggle to 1 meters per second. So I find it easier just to type it in, but you can, if you're a toggle person, you can toggle it. But it doesn't have to be precise, it's just roughly 1. And slide the acceleration toggle to 4, so your man looks like this. So he's got a, so I click somewhere else, notice you got a big green arrow and a small red arrow. Your green arrow, notice, matches acceleration, your red one matches that of velocity. Okay, hit the play button. I'm going to do this one with you so you have an idea what to expect and answer these questions. The rest of these scenarios I'm going to ask you to do it yourself, watch it yourself, play with it. Okay, hit the play button. So we're going to observe your observations for the man before he hits a wall. Well, of course, he's not going to be anything else. Okay, play. Bam. Notice how his red arrow is changing, his green arrow is not changing. And if you caught that, at the very end when you crash into a wall, you see a big green arrow. Now, it's very hard for us to see, and I think it's going to be more apparent when we do the second half of the assignment, where we can talk a little bit more about that. Okay, so you describe how your man is moving. So, as he's moving forward, what do you notice to his motion? Was he speeding up, slowing down, or was it not changing at all? Describe how your green vector is changing. So that's the acceleration vector. So as he was moving, did that change? Did it not change? Did it disappear all of a sudden? C, describe how your velocity red vector is changing. So I was actually paying the most attention to that and talking about that, but notice that red vector, it was started very small in the beginning. As you can see in your assignment, there's a little red vector, and over time that red vector increased. And I wonder if you saw down here in the velocity tab whether or not this number was changing or not. So you can use that to piece the puzzles together, pieces of the puzzles together, and write your description on how your red vector is changing over time. So that is your scenario 1, when your velocity and acceleration are both in the positive direction. Scenario 2. Scenario 2 is when your velocity and your acceleration are in the negative direction. So let's follow these instructions on how to set up. Make sure the velocity and acceleration vector are checked before you start. They are checked, yes. Click and drag the man all the way to the right side if he's not already there. There he is, okay. Hit the pause button and clear the simulation. So it's already paused. I don't need to pause it again. But if you play it, I guess nothing's gonna happen. So pause it. Then clear the simulation. Slide the velocity toggle to about -1 meters per second. I still find it easier just to type that in. Slide the acceleration toggle to about -4 meters per second. Okay, so your man looks like this. Yes, he does. Hit the play button, observe until he hits a wall. Okay, I'm gonna let you do that. You just press the play button, see what happens. Okay, so you do that. Describe how he's moving, what the green vector's doing, what the red vector's doing over time. Scenario 3. Make sure... Okay, so scenario 3 is when you have positive velocity and negative acceleration. So velocity and acceleration are not pointing in the same direction. Make sure to have the vectors checked. Yes, they are checked. Click and drag the man all the way to the left side. Bam! Ouch, that hurts. Hit and pause and clear the simulation. Pause the simulation, clear it. Slide the velocity toggle all the way to 10. Okay, this is when I would just boop, slide the toggle all the way to 10. Then slide the acceleration toggle to -4. So -4 is right there. Hit the play button, record his observations for the man before he hits a wall. Okay, wonder which wall he's gonna hit. Alright, so I'm going to let you do that. It's exactly the same instructions as before. You press the play button, press this play button over here, see how he moves, and wait until he hits a wall. Describe how he's moving, what the green vector's doing, what the red vector's doing. Notice I gave you a little bit more space. Hopefully not that much space. I'm so sorry. But there is a little bit more you might see, so heads up. And last but not least, scenario 4 of part 1. This is where his velocity is negative and acceleration is positive. So the directions are switched for velocity and acceleration, but they still point in opposite directions. So let's see what happens. Make sure the vectors are checked. Yes, they are checked. Click and drag the man all the way to the right side. Bam! And hit the pause button, clear the simulation. Pause, clear. Slide the velocity toggle all the way to -10 meters per second. So velocity is in the other direction. Slide the acceleration toggle to about 4 meters per second. Okay, so it looks like this. Does it match? Yes, it kind of does. Hit the play button. Record your observations for the man before it hits the wall. Describe how he's moving, how your acceleration how your green vector is changing, how your velocity red vector is changing. Okay, so you press this play button, observe. Okay, and that's the last of the last scenario of part 1. Okay, after you're done that, you answer these 2 questions, which is repeated later, but gives you an idea of what's happening. Oh, that shouldn't be there. Oh well. Okay, check your understanding. Next is part 2, graphing. All right, let's take a look what we have. So this is what we have as our first page. The setup instructions tell us to click the charts tab at the top of the Windows page. So that part. And there it is. Click the charts. Your simulation should look like the picture on the right. So yes, it looks like this. There are 3 charts: position time graph, your velocity time graph, your acceleration time graph, and you have the moving man at the top. Now, so it looks like that. Make sure you have the velocity and acceleration vectors checked off. Again, this is to help you. It's not so much needed. It's not really the focus of this part of the assignment, but I'm just going to leave it on. Done. Scenario 1. So we're going to be speeding up in the positive direction. And the reason why I set these numbers is so that you don't get any crazy looking motion where you won't be able to observe the full graph that I want you to be able to see. And of course, you can play around with it and see what happens when you do change position, velocity, and acceleration from the values I've given you, just to give you a sense of how it affects your graphs. But this is the base. Scenario 1. Type in the following for the man's position, velocity, and acceleration. So we're going to put them all the way at -10. So we're going to type these in. -10, 0, and 1. 0 and 1. Okay, so we did. Now what? Hit the play button and observe the man until he crashes. Very nice of us, aren't we? Okay. Okay, so it looks like this on your screen, where you have a little green vector showing for acceleration. Hit the play button until he crashes. Sketch in the position, velocity, and acceleration time graphs below. You might want to hit the zoom button. Okay, so I'm going to do this with you, just to give you a sense of what's happening. And I'm going to ask you to do actually, I'm going to do one more, but the 2 of the 4, I will show you what it looks like. The other 2, I'm going to ask you to do it yourself. Okay, so I'm going to hit the play button to show you what to expect. So he is moving forward. Notice as he is moving, the graphs are being formed. Okay, and then he crashes. And I just press the play button so this graph doesn't keep going. Now we would draw them in. We hit the zoom button for, if we need to zoom in, you have this little button here at the top where it says zoom in. So right over here for each of these graphs, and for velocity position is not as needed, but it's very hard to see the acceleration values here. So I'm going to zoom in here and show you, see if we can make that bigger. Okay, so that's the closest we can zoom in, and notice that the line is above the x-axis, and that's what I wanted to show you. Okay, I mentioned this earlier where the moving man, the green vector, suddenly became negative and was a huge arrow. So if you take a look at this graph over here, the acceleration time graph, notice the graph dips down into the negative values, and it keeps going, and we saw before it was a very high value. We can actually put that into perspective and try to make meaning out of it. If the man hits the wall, what is the wall doing to the man in order for him to stop? The wall has to exert some sort of force, so the man goes from some positive velocity all the way to 0. So in that sense, he is slowing down, but he's not just slowing down slowly, he's slowing down in almost a split second. So to slow down that quickly, he needs an acceleration in the opposite direction in order for him to come to a stop right away. So that's where that huge negative acceleration vector came in, so that he was able to stop in time, which is why it hurts when you have to press on the brakes when you're driving at a very high speed and you suddenly see a pedestrian. Anyhow, so that is that's putting that huge green acceleration vector's perspective, that's where you see a dip in your acceleration graph. Notice your velocity time graph does the same thing, where it suddenly becomes 0. And when we talk more about these graphs in class, we can talk about slope on a velocity time graph and what that means, and how to extract acceleration from velocity time graphs. Okay, so that is your first scenario. You draw these graphs in, and you're welcome to draw these parts, these nicks and whatnot. If I were you, and I would actually write some notes on what they mean so you can refer back to them later. And you won't be handing that one in because I'm only getting your exit slip, so you can keep this part of your assignment. Moving on. Scenario 2. We have a different one, speeding up, but it's in the negative direction. So now we're going to type in the following for the man's position, velocity, and acceleration. So we're going to move him all the way to position 10. He's already there. Velocity 0, -1 acceleration. Velocity 0, -1. Okay. Not yet. Hit the clear and then play the button. Then the play button and observe until he crashes. So we're going to clear it first because we want a new fresh sheet graph. We want a new graph. Then we hit the play button. You play the scenario. You draw it in. See what happens. There you go. And of course, zoom in if you need. Scenario 3. Whoopee. Okay, so now we have a different, something else is happening now. We are not speeding up, but we're slowing down in the positive direction. Let's see what that happens, what that looks like. I made the position to be 0 so that you can see, you get an idea of something else that may happen. Okay, so position of 0, 5 meters per second, -1 acceleration. So that's 0, 5, -2. Oh, hey, I'm putting acceleration as negative. Let's see what happens. And I'm actually going to do this one with you because I want to talk a little bit about the instructions here. You want to hit the clear and then the play button, and pause the man until he stops and he goes the other direction. So when he stops, he's about to go in the other direction. That's where I want you to pause because that's the part of the graph that I want you to draw. You're welcome to unpause it to see what happens. And we'll talk about it in a sec, in fact. So I'm going to do this with you. So I'm going to play this. I'm going to play. Oh, hey, he stops about there. And that's where I want you to pause the graph. Pause the simulation and draw that part of the graph. Okay, this is the part of the graph that I want you to draw here. Okay. Now, if we unpause the simulation, let's take a look at what he's doing. Notice he's going backwards, and ooh, he is speeding up. So, where my mouse is going through the graph, that is where you are asked to draw. Everything that happens afterwards, take a look at this graph. It starts to curve downwards. I wonder where you've seen that before. Something to think about. Because this is the first part of the motion. The second part, he is stopped. And now, as you saw him moving, he was moving backwards. But what was he doing when he was moving backwards? And you said it right, he is speeding up. Isn't that similar to a previous scenario where he's speeding up but in the negative direction? Scenario 2. Interesting, hey? So, that is what I wanted to talk about. And that's why I want you to stop it before he goes in the until he stops and goes in the other direction. This part here, the second part, is not slowing down, of course, it's speeding up, which is why I want you to pause it there, okay? But you're welcome to draw it in your graph, write a note to yourself for future reference. Okay, let's move on. Scenario 4, slowing down but in the negative direction. So we're flipping everything that we have. Position 0, -5, acceleration 2. Position 0 and -5 and acceleration to 2. Okay, so it looks like this. We have to clear it. So here it says hit the clear and play button. Clear and then play it. And again, it tells you to pause the man until he stops and goes the other direction. Okay? And same thing as I said before, you're welcome to unpause him later to see what he does and make the connections yourself. But this is very similar to scenario 3, where I want you to pause in between, not when he crashes, when you pause in between his motion, draw only that part of the graph, okay? And that's down here. So that's scenario 4. That's the end of our simulation part of our assignment. And this last part, you're just asked to check your understanding, circle a few things, match a few things. Basically, it's just going over what happens when acceleration velocity vectors point together or in the opposite direction. What does negative acceleration mean? And what do these graphs describe? How does the curvature of your position time graph look like when your object is speeding up, slowing down, etc.? Okay? So that's it. If that's the end of your assignment. So please hand this in at the end of class to show me what you know. And you're welcome to keep the rest of the assignment for studying for a test or something, or a quiz. All right. Well, thank you for watching. Hopefully you learned something from this simulation. If you have extra time, feel free to play around with it. Otherwise, good luck and see you next time.